and welcome back to Science with Mack. On today's video, we're going to talk about something I absolutely love, calorimetry. But before we get into the nitty-gritty, many of you may be asking, what is it?
Calorimetry is a measure of the amount of thermal energy transferred in a chemical or physical process. This requires careful measurement of the temperature change that occurs during the process in the masses of the system and the surroundings.
I know that can seem like a lot, so let's break it down. Calorimetry is an important concept in the field of thermochemistry. Thermochemistry focuses on the energy associated with bond breaking and bond forming processes.
Bond formation is always an exothermic process which produces energy as a product of a reaction, while bond breaking is always an endothermic reaction and requires energy as a reactant.
The energy required or produced by these two different reactions can be measured using calorimetry. It measures the amount of heat transferred to or from a substance. The specific tool utilized by mad scientists like ourselves for calorimetry is a calorimeter. This well-insulated device maintains the transfer of heat between the calorimeter and its environment.
For a cost-efficient but still an overall effective calorimeter experiment in a lab setting, styrofoam cups can be used. Pro tip number 1. When setting up a calorimeter, it is very important to use strong insulators that keeps heat contained inside the device.
First, you're going to place the styrofoam cup into the other. This way, you have an established system and surroundings.
In this example, the surroundings are the water in which the solids have been dissolved and the calorimeter itself, while the system are the dissolved substances.
While the reaction occurs in our special cups, the thermometer is going to rise or decline depending on the type of reaction that we are measuring.
Pro tip number 2. Accurately reading a thermometer during experiments is crucial in understanding what reaction is occurring and measuring the heat transfer.
If it is exothermic, the temperature of the solution, also known as the surroundings, is going to increase as heat energy is transferred from the system to the surroundings. And on the flip side, if it is endothermic, the temperature of solution is going to decrease as the heat energy is transferred from the surroundings to the system. Now, I bet you are all wondering, why would we ever need to know this? As we know, one important way calorimetry is used in the scientific lab is through monitoring chemical reactions and reactions between different compounds or elements. However, calorimetry can also be used with food.
The food you consume on a daily basis releases heat when it is broken down, making it an exothermic reaction. Food calorimetry allows for us to determine the number of calories per gram of food. The energy released when the food item is burned heats the surrounding water, and then the change in temperature is used to determine the amount of energy in food.
Well, I hope you've learned a lot about calorimetry, and your fascination with it is just as much as mine. I'll see you next time on Science with Mack.